So with double angle identities, what I first want to emphasize to you is that we are literally doubling the angle. So for example, let's talk about the sine of 2 theta. So let's go ahead and say that we want theta to be 45 degrees. So we've got a 45 degrees here and a 45 degrees here. So if we use this identity, we got 2 sine of 45 times the cosine of 45. The sine at 45 is the square root of 2 over 2 times the cosine of 45 is also the square root of 2 over 2. So we've got 2 over 1 times square root of 2 times square root of 2 is 2. And 2 times 2 is 4. And then we end up with 4 over 4. So then that's equal to 1. Well, that should make sense because over here, remember we said that that theta was going to be 45, right? Well, 2 times 45 is 90. Is the sine of 90 1? Yes, it is. And 45 doubled is up to 90, right? So we are literally doubling that angle. Now, the reason why I want to emphasize that so much to you is that sometimes the signs of sine, cosine, and tangent might be different than what we expect. So for example, here in a moment, you can see at the bottom of the screen, we have if sine is negative 7/25 from pi to 3 pi over 2. That guy's in my third quadrant. I know that in the third quadrant, sine and cosine are both negative. But if I double that angle, sine and cosine might not be negative anymore. Do you see what I'm saying? Because we were in the third quadrant, and then when we double that, we're back over to the first or maybe, fourth, second, somewhere in there. So don't worry about those signs. They will work themselves out. All right, here's the next thing I wanted to talk to you about. So we have the identities over here on the side of the screen, and we have that cosine of 2 theta is equal to 3 different things. I want to emphasize to you that all of these are the same thing. So we know that cosine squared plus sine squared is equal to 1, right? So be really, really careful about that when you're using this sign in the middle. He's going to be subtracting. So let me show you how all of these fit together. So first of all, we know that cosine squared plus sine squared equals 1. So then we know that cosine squared is equal to 1 minus sine squared. And that sine squared is equal to 1 minus cosine squared. So if we take this original guy and we put in what we know cosine is equal to, so cosine squared is equal to 1 minus sine squared, and then we still have that minus sine squared. So that's how we get that 1 minus 2 sine squared theta down here. We also know that sine squared is equal to 1 minus cosine squared. So if we plug him into this sine in our original guy, our sine squared there, we've got cosine squared minus, and then sine squared is 1 minus cosine squared. We distribute through that negative. So now he's a plus. And then cosine squared plus cosine squared is 2 cosine squared minus 1. So it's all the same thing. All of these 3 are equal to the same thing. Just you kind of have to be a little bit choosy about which one to use, especially when we start solving equations here in a little bit. So I'll show you what I mean. Okay, so If the sine of theta is equal to negative 7/25 from pi to 3 pi over 2, so that means we're in the third quadrant down there, we want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So since we're in the third quadrant, I went ahead and drew a little graph with the third quadrant over here. I'm going to go ahead and draw a triangle here in this third quadrant. We know that our triangle should always be made with the x-axis. Do you remember that from Unit 3? Always made with the x-axis. So we have a theta right there. Theta is always made with the x-axis. Now sine, remember with the SOHCAHTOA kind of stuff, he's the opposite over hypotenuse, right? So that means this side is negative 7. Our hypotenuse is 25 because the hypotenuse is always positive. If we do the Pythagorean theorem, negative 7 squared plus x squared equals 25 squared, we're going to end up with 24 for this length over here. But since we're in the third quadrant and we're going to the left, that means that 24 is negative. Okay, cool. This is just something that I do because it helps me out. I like to have somewhere that I know sine is negative 7/25, and then also cosine adjacent over hypotenuse is going to be negative 24. I'm sorry, over 25. There we go. So those are two pieces of information that's going to be super helpful to us. So when we look at our identity for sine, our sine double angle identity, he's going to be 2 sine cosine. So here I've got 2 sine cosine. I'm going to put that 2 over 1 times. We know sine is negative 7/25 times, and then cosine was negative 24/25. So if we, if we take 2 times negative 7 times negative 24, we're going to get 336. And 1 times 25 times 25 is 625. So this is my sine of 2 theta. Now we'll find cosine of 2 theta. So cosine of 2 theta, we have 3 different options there. It doesn't really matter which one you use. If you tend to make silly mistakes, my advice is use the identity that they gave you the value of. So since they gave us sine, it might be smart to use 1 minus 2 sine squared. So that way it's a little less, if you made a mistake finding cosine, you're not going to have any issues finding your double angles. Do you see what I'm saying? So if you made a stupid mistake, it's going to save you from those mistakes affecting your work. So it's up to you. Anyways, so let's maybe use the one that has sine in it. So that guy is going to be 1 minus 2 sine squared theta. So I've got 1 minus 2 times sine was negative 7/25, and he's squared. If you want to throw it in your calculator right now and then click math and then frac and enter and giving it to it as a fraction, wonderful. I'm still going to talk you through it just so you know how to do it. So when we square a fraction, don't scare it, square it. Sorry, guys. All right, so negative 7 squared is 49. 25 squared is 625. We still have that being multiplied by 2 and minus 1. Okay, so then we'll multiply those together. 2 times 49 is 98 over 1 times 625 is 625. Now I have 1 minus over here, right? I'm going to rewrite that with common denominators. So I'm going to write 1 as 625 over 625. So 625 minus 98 is going to give me 527 over that common denominator of 625. So there is my cosine double angle identity. Okay, so if we have tangent here, tangent of 2 theta is going to be equal to, well, tangent is equal to sine over cosine, right? So tangent of 2 theta is going to be equal to sine of 2 theta over cosine of 2 theta. Sound good? Cool. Now, the reason I'm telling you that is because, yeah, we have this tangent identity, and you'll need to use the tangent identity in one of the problems on your practice because all it asks for is tangent. But if you're finding all three, here's what I would do. We know that tangent is sine over cosine. So I'm going to take our sine, 336 over 625, and divide that by my cosine, 527 over 625. So then we're dividing by fractions, so we're going to multiply by the reciprocal. So we have 336 over 625 times 625 over 527. Those 625s are going to cancel out. And I got 336 on top, 527 on the bottom for our tangent of 2 theta. All right, let's solve a couple of equations now. So we want to find all solutions. So just a little bit of a reminder, when I say all solutions and there's no interval in there, like 0 to 2 pi, something like that, that means that you're going to have equations. So we got the sine of 2 theta minus sine equals 0. So we need to replace sine of 2 theta with something that we know. His identity says that the sine of 2 theta is equal to 2 sine cosine. So I'm going to change this to 2 sine cosine. Then we still have minus sine equals 0. What you might notice about both of those terms is that they have a sign. So we'll factor this sign on out. Remember, when we factor out, that means we divide. So when we take 2 sine cosine divided by sine, the signs cancel out, so we're left with 2 cosine. Minus sine divided by sine is 1. Now we'll use that zero product property and set sine of theta equal to 0. 2 cosine of theta minus 1 equals 0. So we know right here that we got cosine of theta equals 1/2. Okay, so now let's write out all of our solutions. So where is sine equal to 0? Well, it's equal to 0 at 0 and pi and 2 pi and 3 pi and 4 pi and so on and so forth, right? So if you wanted to tell me it happens at 0 and then you add that 2 pi n for the period, and then it also happens at pi, so then you add 2 pi n for the period, I would be so happy with that. Or we know this is happening at every pi, so you can just call him pi n. You do not have to put the red part. If you got the blue part and you're cool with the blue part, keep the blue part. I'm jazzed with it. But some people get a little bit annoyed because it's like, why do I have to write 2 equations when I can write 1 equation that's way shorter and takes care of all of my answers? Go for it. No problem at all. Cool, now let's deal with this other side. So where's cosine equal to 1/2? Cosine is equal to 1/2 at pi over 3 and 5 pi over 3. And we'll add 2 pi n to both of those. Good deal. Okay, I don't really have a lot of room for b. I'm going to put b down here. So we got the cosine of 2 theta. Is it minus or plus? Minus 2 cosine. I think I have this written down wrong. Hang on. Yeah, the first one's squared. Here we go. Minus cosine of 2 theta equals 1/2. Okay. So when we are looking at these identities, we have to figure out which one of the cosine identities is going to help us out. So we want to replace my cosine of 2 theta. The other stuff that I have in my equation is a cosine, right? So that means that I want to choose my cosine double angle identity that only has cosine in it. So I'm going to use this middle one right here because he only has cosine. Are we cool with that? All right, so we're going to keep cosine squared the way it is, minus. And I'm going to put parentheses here so that way I don't lose that negative at all. So cosine of 2 theta is 2 cosine squared minus 1 equals 1/2. We need to make sure to distribute that negative on through. So we've got a cosine squared minus 2 cosine squared plus 1 equals 1/2. So now we're taking cosine squared minus 2 cosine squared. So think of that almost as x minus 2x. We're going to end up with negative 1x, right? So cosine squared minus 2 cosine squared is negative 1 cosine squared. And we still got a plus 1 equals 1/2. So we'll start trying to get cosine by himself. We'll subtract 1 on both sides. So we have negative cosine squared. 1/2 minus 1 is negative 1/2. Then we'll divide by negative 1 on both sides. So cosine squared equals 1/2. Then we'll take the square root of both sides. The square root of 1 is 1. Gotta get a plus or minus out in front of that. And the square root of 2 is the square root of 2. Now, don't get freaked out. This is not scary. This is not weird. All you have to do is rationalize your denominator, and then you'll recognize that coordinate. So to rationalize, we need to multiply by the square root in the denominator. So 1 times square root of 2 is square root of 2. Keep that plus or minus out front. Square root 2 times square root 2 is 2. So we want to know, where is cosine equal to either positive square root 2 over 2 or negative square root 2 over 2? All right, well, let's start listing out our answers. That's going to happen at pi over 4. And then we still need that plus 2 pi n. Happens again at 3 pi over 4 plus 2 pi n. Then 5, theta equals 5 pi over 4, there we go, plus 2 pi n. And then it happens again at 7 pi over 4 plus 2 pi n. And if you put all of those answers, I would be jazzed and happy as heck. Or if you're like, that's a lot to write, and so I see a simpler way to do this, that's totally fine. We know that it's going to happen at pi over 4, where cosine is going to be equal to either positive square root 2 over 2 or negative square root 2 over 2. Now to get from pi over 4 to 3 pi over 4, that's half of a pi, right? So I'm adding a half pi every time. So you can also put pi over 4 plus 2 pi n. That's fine with me too. All right, guys. Hope you have a wonderful day. See you guys later.